Hey students, what's going on? This is 2.4 notes. We're talking about atoms and nuclide symbols. So what I need you to do right now is I need you to copy in this top part here so you're ready to go on it. And that way we can start taking those notes. Hit pause so you get there and then we'll get rolling. All right, so here we go. The atom. So the first part is we're going to start talking about the part that makes up the atom. So within the atom, all right, our atom is the smallest indivisible part of matter, so it cannot be divided any further and keep its properties. So that gives us inside the atom, there are things that are called subatomic particles, and that's what makes up the atom. So inside the atom, the center of the atom is our nucleus. All right, so the center of our atom is the nucleus, and the nucleus holds the protons and neutrons. And this is also probably the most massive portion of the atom. And when we talk about massive, we're talking about mass. We're not talking about in terms of size because it's actually very, very small, but it makes up most of the weight or mass of an atom. Within the nucleus, we have protons, and protons are positively charged particles. So positively charged particles chilling in the nucleus, their claim to fame and what they do is they are known to identify the element. All right, these identify the element. So however many you have, if you have 6, then that element is carbon. If you have 12, I believe you have magnesium. Yes, all right. So our protons inside the nucleus, they're positively charged. They identify the element. All right, then we move to our neutrons. Our neutrons have no charge. So we're going to say um, particle with no charge. No charge within the nucleus. So also within the nucleus. But it's also very massive because, whoops, can't spell nucleus correct. Let's try that again. See if I can erase that. There we go. All right, so it's no charge within the nucleus. This is very massive, all right? So also big because the nucleus, we think, is made up of a proton and an electron, which we'll get to in a couple of seconds. So it's actually a little bit more massive than a proton, but for our purposes, we're probably not going to differentiate between the weights or the masses of those two. Now, the neutron's claim to fame, all right, while we think it might not be very important, some of us might think it's not very important, it's actually very, very important. What do we know about positives when they come together? They tend to repel each other. So our neutrons keep our positives, keep the protons from getting too close to each other and thus exploding the atom. Right, we really don't want that. And so real quickly, our abbreviations for a neutron is N to the 0, our proton is P with a plus, right? Positively charged, and the neutrons have no charge. All right, so that's the nucleus. That's the massive part. Now, in terms of the size, that's our electron cloud. Our electron cloud is a very huge space, and it is the highest probability of finding an electron. So, where is the highest probability of finding you during this class? Hopefully, it is in the classroom, but obviously, if you're watching this video, probably not in the classroom that day. So, the highest probability is finding you in the classroom, but some days we know that's not true. You might be in the bathroom, you might be at home, you might be wherever. Okay? Our electrons then are negatively charged particles. They are very, very small. Very small. Okay? I don't know why I put the small a on there. All right, they are very small. Okay, very small. The claim to fame for electrons, the abbreviation for electron is e to the negative. Our claim to fame for an electron is that it is involved in bonding. This determines how an atom will bond, which, as you'll see with the rest of the year, we'll spend the rest of the year working on bonding. So very important, even though it's such a small little thing. All right. Now let's talk about counting particles. So we've talked about the atom, what makes up an atom. Now, how do we represent a specific nuclide or a specific atom? So we don't have to write it all out, 15 protons, 15 neutrons, whatever. All right, so we're going to do that with what is called a nuclide symbol. So we're going to start with what is an atomic number. An atomic number identifies the atom. And if you refer back up top, we said that the proton is are how we identify the atom. So atomic number and number of protons are exactly the same thing. Our mass number tells us the size or mass of an atom. And how we find that is we take protons plus neutrons. So pretty simple there. And finally, what we have is the nuclide symbol. And this is like a shorthand for an element. Okay, this next part I'm going to blow up a little bigger here. All right, how we find that is we take the mass number, starting with the wrong thing there. We take the mass number on top as a superscript, then we put the atomic number on bottom, then we put the element symbol, and then next unit, we're going to learn to put our charge there. All right, for our purposes, we've got mass number, atomic number, and then the element symbol. And this will be next unit. All right, so next unit, we won't see that until next unit, but it'll come up there. Okay, so let's talk about, we've got this handy dandy table here. How do we fill out this handy dandy table? So our mass number, this top row right here, is just going to be the how-to. All right, so we can refer back to it, the how-to. Okay, so we're going to just repeat what we just did there for our, we've got our mass number on top. Atomic number is our subscript. We've got the element symbol, and then eventually we'll have charge, but not this unit, all right? So this is going to be empty for right now. Okay, if we look at atomic number, we said how to find it is it's equal to the protons. And for right now, it's going to also be equal to the electrons because positive charges should equal the negative charges in an atom until we start bonding, and then we'll get to that, like I said, next unit. All right, mass number, remember, is our protons plus our neutrons. So we find mass number by taking protons plus neutrons. Remember, our protons are equal to our atomic number. Our neutrons then are going to be equal to our mass number minus our protons. And last but not least, for right now, our electrons are going to be equal to our protons. Again, this is for right now. Next unit, this will change. Okay. Ooh, getting near the side there, hard to say that, so it'll change next unit. All right, so let's see if we can't put this into play. Right now, we don't even need a periodic table to look at unless we're looking for its symbol, which we probably should for this first one. So remember, we said that the atomic number is the one that identifies the element. So we're going to look right here, 6, and we're going to see that 6 is carbon if we're looking at our periodic table. So the symbol for carbon is C. On bottom, we're going to put the atomic number. On top, we're going to put the mass number. So far, so good. Remember, our atomic number and our protons are the same, so this should also be 6. To find neutrons, we're going to take mass number minus protons. 14 minus 6 gives us 8. And then last but not least, our protons and electrons are equal for this unit. So that's one way to do it. All right, let's see if we can't see what we've got with kind of a different one. This time we're given protons, neutrons, and electrons. And we want to work kind of backwards, if you will. All right, so remember, protons plus neutrons gives us our mass numbers. So 8 plus 8 is 16. Remember, protons and atomic number are the same. So for our nuclide symbol, we're going to have 16, 8, and then we look on our periodic table for which one is 8, and that is oxygen. So that's why I put O right there. Okay? All right, I want you to work this last one on your own. I will work it, but I will work it quietly. So please take the time to work this one on your own. If you didn't have time, go ahead and hit pause, right, and see how you did. Thank you. That is all for this video.